Welcome to Web Handling. My name is Dave Roysum. I am super excited to continue Dave's Defects with a discussion of splices. Whether you do lap or butt splices, and whether your splices are completely automatic or completely manual, or somewhere in between, you know that few splices are trouble-free. In this short clip, we will outline a few of the splicing methods as well as concerns. In my 2-day winding class, we go into great detail into the various methods to attach a tail to a core. We also show the physics of loose cores and why glue or tape or any attachment method will not help in the slightest to prevent loose core complaints. It is the radial pressure that helps keep the cores and wound rolls together. But even that may not work in certain cases, such as fiber cores drying out and rolls wound with stiff webs. This case is also covered in our class. The goal is simple: to get the first wrap straight and neat. This will reduce or prevent many problems near the core, including wrinkles, telegraphing, and web wander. Well, it turns out that many of these same tail-to-core attachment options are also options for butt and lap splices. It also turns out that getting the splice flat and straight and neat also matters a lot for splice reliability, just as it does for wound roll quality. There are two goals for all splices: speed and reliability. Speed is measured as the time to complete the splice cycle. Speed varies from a few milliseconds on automatic splicers to perhaps minutes on a completely manual splice. Reliability is measured in several ways. One that is often overlooked is path stability. All splices are crooked to some degree, and they act just like a misaligned roller. We cover path upsets in great detail in my award-winning and trademarked Web 101 class. Runnability is another area of concern. The length of double thickness cannot snag as it goes through the machine. Occasionally, splices are done at a small angle to improve runnability. Runnability is also affected by the in-situ MD tensile strength of the splice, which can be measured on some rewinders, compared to the strength of the unspliced web as quite commonly measured in the test lab. Some splices are a good fraction of web strength. Others are far weaker. The composite runnability of the splice operation is measured as 1 minus the miss rate. This reliability can vary from 90% on a non-demanding process to better than 99.9% for high-speed operations such as you might find in paper or fiberglass or steel mills. We teach how to troubleshoot misses in our advanced winding class. In many ways, splicing errors are much like registration errors in printing. The two tails may be offset, angular, narrow, or other. It is the angular splice that is most common, most serious, and most difficult to see and solve. Milliradians matter with splices, just as they do with roller alignment. There are several places where you can learn more about splices. Probably the best is to go to school so that you understand the first principle about things like path control, strength, tension, runnability, and so on. If you look up Splices in the free and easy Roysum library database by Abbott App, you will find more than 40 publications. Finally, it is a good idea to talk to your suppliers as well as their competitors. However, you can't necessarily totally trust what suppliers say. Beyond that, they can and would sell you certain equipment and supplies. You may have to do experiments and testing and diagnosis of runnability yourself. Thank you so very much for joining me in this defect solving and defect preventing series. Stay tuned for the next clip where we will talk about one of the most common of winding defects, the many forms of telescopes. Let me know if you have a defect you would like to hear about. If you found anything interesting or useful here, please like and share and subscribe. Also, please consider supporting the work of this channel using the Patreon link below. See you next time.